All right, this is the final recording for topic 9. And we just finished with our example of a Z-test with comparing Bakersfield student SAT verbal skills to national average. And now we're going to go on. So confidence intervals, we use confidence intervals to describe limits on what we reasonably expect population mean to be given the sample mean. So that the idea is that we got this sample mean, what can we expect the population mean to look like? And we are going to get a range of values, okay? This is another way of to test hypotheses. So confidence interval approach always is going to result in the same decision about whether to fail to reject or reject the null hypothesis. It's just the same numbers rearranged, right? And we'll get to that later. So just to repeat, the one sample Z-test compares a sample mean against a hypothesized population mean. You must know the population standard deviation and the hypothesized mean for the population, right? So for example, the average national GRE score with quantitative and verbal for graduate admissions to clinical psychology is 1,150 with a standard deviation of 250. So you might ask, do CSU students generally need higher scores for admission? So based on a sample of 400 CSU students admitted to clinical PhD programs, the average GRE for these students was 1,175. So 25 points higher. Is this different, right, than the average of 1,150? So let's show the operations. You just plug it in, Z, right? You go 1,175 minus 1,150, right? You get 25, and then it is the standard deviation of the population divided by the square root of the sample size. We carry out the math and we get 2, which we already know is a pretty big Z-score, right? This is we compare the 2 to, is it more extreme than 1.96? Yes. Our conclusion, reject the null. Then we have plain English. CSU students have higher average GRE scores than found in the population of clinical psychology admissions. And we can make a confidence interval, which we'll get to later, right? Okay. So if we use confidence intervals instead, confidence intervals provide an estimate of where it's likely to be, right? When we just have a mean for the sample, what is our best guess of the mean for the population? Confidence intervals yield a wide range of estimates. So if we just get the mean is a point estimate, right? The confidence interval is a range, okay? 95% confidence is this interval is the same information as the Z-test in a different matter. So in this example, we get this, we can say the range likely in the population is between 100, for CSU students is 1150.5 to 1199.5. Remember, we are comparing them to 1150, so they are slightly, this confidence interval does not include our test value of 1150. So we're still going to reject the null hypothesis and say, hey, we have evidence to show that CSU students do better than the average for admissions to clinical psychology programs, right? Hope that makes sense. Okay, so null hypothesis testing strategies. We've started with the Z-test. It's good introduction, but it doesn't do much good because it requires knowledge of the standard deviation in the population. We are going to proceed to the T-test, comparing means between 2 groups or a single sample. One sample independent means and paired T-tests. We're going to talk about ANOVA that compares means across more than 2 groups because T-test just 2. Correlation regression, chi-square, and so forth. Any procedure that leads to a conclusion regarding whether we can reject some null hypothesis is what we call a null hypothesis significant testing procedure. Okay, so now we're going to go on to kind of delve into that a bit. So here's the statistical decision-making process. So we have here on the left reality, right? In reality, null hypothesis is true or null hypothesis is false. Our statistical decision is either to reject it or to fail to reject it, right? So there are 4 possibilities here, as we can see, okay? We can have what we call a false positive. We can reject the null when the null hypothesis is actually true in reality. This is a type 1 error, also called an alpha error, right? The probability of us making a type 1 error is equal to alpha, so generally 0.05. That is the probability we make a type 1 error. Okay, we can also make the wrong decision, right? If we fail to reject a null hypothesis that is not true, right? This is a false negative, okay? We should reject it, but we don't, right? This is called a type 2 or beta error. Then what if the null hypothesis is true and we fail to reject it? This is the correct decision. Sad researcher, because we do not want to find evidence that we're wrong, but it happens quite a bit. Finally, we have the best case scenario when we correctly reject a null hypothesis that is false, okay? This happens when we have enough power to reject it. That's statistical power, which we're going to talk about.